Hello, I'm honored to host today's seminar, Reproducibility and Open Scholarship, National Academies Efforts and Roles for Societies. This seminar concludes a year-long seminar series called Data Sharing Seminar Series for Societies. My name is Philip Rubin, and I'm here today in my capacity as the incoming president of the Federation of Associations in Behavioral and Brain Sciences, or FABS, a coalition of 28 scientific societies and 60 academic departments that come together to advance these disciplines. FABS is pleased to be one of the 11 societies and federations collaborating on this effort. We are joined by the AAAS Science, the American Astronomical Society, the American Chemical Society, the American Geophysical Union, the American Meteorological Society Board on Data Stewardship, the British Ecological Society, the Council of Scientific Society Presidents, the Ecological Society of America, the Federation of American Societies for Experimental Biology, and the International Union of Pure and Applied Chemistry. Data sharing is central to FABS and its members. We look at big picture issues for our disciplines, including countering data bias, reproducibility and robustness of data, and sensitivity to issues of diversity, equity, inclusion, and accessibility. This includes the work that needs to be done to make data sharing meet FAIR standards, that is, data that meets standards of findability, accessibility, interoperability, and reusability. Over the years, we've been engaged in a number of efforts to support our sciences to advance the goals of data sharing, open science, and public access to research results. One recent example this year was a webinar series on data standards for behavioral and brain sciences that included participation by the National Science Foundation, the National Institutes of Health, and partnering with other professional societies. Federal funders require data sharing with increasing attention to discoverability. Beyond compliance, there are numerous compelling reasons to share data in a way that facilitates increased searchability, effectiveness, and rigor of science. This webinar series was designed to educate FABS members and others on the expectation of funders, the opportunities afforded by sharing, examples of effective databases and repositories, and clear steps forwards to advance individual efforts and interoperability of data. With this being said, it is my pleasure to introduce our speaker for today's webinar, titled Reproducibility and Open Scholarship, National Academies Efforts and Roles for Societies. Marcia McNutt is a geophysicist who is the president of the National Academy of Sciences. From 2013 to 2016, she served as editor-in-chief of the Science family of journals and led their editorial team and their decision to enter the world of open access publishing. Prior to joining Science, she was director of the U.S. Geological Survey, USGS, from 2009 to 2013. Before joining the USGS, Dr. McNutt served as president and chief executive officer of the Monterey Bay Aquarium Research Institute. During her time there, the institution became a leader in developing biological and chemical sensors for remote ocean deployment, installed the first deep-sea cabled observatory in U.S. waters, and advanced the integration of artificial intelligence into autonomous underwater vehicles for complex undersea missions. She's a foreign member of the Royal Society and a member of the National Academy of Sciences, the American Philosophical Society, and the American Academy of Arts and Sciences. She's a fellow of the American Geophysical Union, the Geological Society of America, and the American Association for the Advancement of Science, among others. We're delighted that she could be with us today. I will ask that you keep yourself on mute during the presentation. Please feel free to type your questions into the chat box or use your virtual hand raise function. We hope to have plenty of time for questions after the presentation. If you haven't already done so, please include your name and where you are from in the chat. Marcia, it's yours. Welcome.
Well, thank you very much for this overly generous and perhaps to the listeners, very long introduction. It's my pleasure to be with you today. I believe Dr. Rubin has already listed most of my relevant relationships that have certainly shaped my opinion on these issues. One is, of course, as president of the National Academy, an organization which does work in this space. Also as a former editor-in-chief of Science Magazine, we did quite a lot of work in reproducibility and open science. And the one thing that wasn't mentioned is I am on the board of directors of the Center for Open Science in Charlottesville, Virginia. So let me begin by sharing my screen to go through a few slides. So are you all seeing these? Give me a thumbs up if you can see these.
Looks good.
Yes.
All right, good. Okay, so you already heard the title of my talk. So let's go on to, here's just a quick outline of what I hope to cover in my 20 minutes or so here. I'm going to tell those of you who might not be familiar with it, what the National Academies is all about. Give you an overview of our activities related to reproducibility and open scholarship. Tell you about ongoing and future planned activities. And then finally, I will get to what probably all of you are most interested in, and that is the key tasks and roles for scientific societies in advancing open scholarship and reproducibility and replicability. So first of all, for those of you who are not familiar with the National Academies, and I see we have one person tuning in from Thailand, which is fabulous. The National Academy of Sciences was founded more than almost 160 years ago now as a private nonprofit institution. We're a membership organization and we elect our own members. And for the National Academy of Sciences, they're the most eminent scientists. We also have two partner academies that were established in the 1960s or 1970s, so that elect engineers and medical professionals. Our charter is to advise the federal government on all matters in which evidence can inform better policymaking. That charter was signed by President Lincoln. And in terms of our advice to the government, we are organized in 7 major divisions, each of which has a number of standing committees and ad hoc committees underneath it that cover things like health and medicine, engineering, earth and life studies, social sciences, education, etc. The main ways that we provide that advice to the government is through consensus studies and convening activities such as workshops and roundtables where we get the stakeholders together. And then we also operate a number of programs such as fellowships. One of our programs that some of you may have participated in is our teamwork with Hollywood to get better science into Hollywood productions. Now let me go on to the topic of reproducibility and open scholarship and tell you some of the things that the Academy is doing. This report, Fostering Integrity in Research, was published in, I believe, 2015 or 2016. And this has been a fairly influential document that has updated the issues of plagiarism and falsification and fabrication to the modern era. Oh, here's the date. It was released in 2017. It examines factors that affect research integrity, such as research misconduct and also detrimental research practices. And those include things like ghost authorships or honorary authorships, anything that would cause someone to mistrust the scientific item. This report was supported by federal agencies and several societies, foundations, and also by the Academy itself. The key findings and recommendations from this report are that openness and accountability fosters integrity and improves the quality of research. It recommended that a new organization be established to strengthen institutional capacity to address threats to research integrity. The publishing world has COPE, which helps publishers be more ethical. And funding agencies have their AGs and other groups that help them make sure that funding is given out in a manner that has high integrity. But there's no organization that crosses all of the stakeholders in research, including research institutions and those who use the results of that research. So this report recommended that there be established this new organization that crosses all stakeholders. And I'll tell you more about that later. Another project that we did recently was one titled Open Science by Design, Realizing a Vision for 21st Century Research. The context for this was released a year later after Fostering Integrity, and it identified actions needed to move toward open science as the default for sharing research results. So no more, if you want to get the data, or if you want to get the methods, or if you want to get the code, you have to contact the author and count on them to do it. But open availability of all these essential elements of the research should be the default. This report was supported by the Arnold Ventures Fund. And the key findings and recommendations from this report are that the open science process itself should empower researchers to do better research. And it recommends actions to strengthen education, culture, data sharing, reuse, and supportive funding policies. The main thread in this report is that you have to make it clear to everyone what is the right thing to do. Then you have to make it easy for them to do the right thing. And then finally, you have to reward them for doing the right thing. Here's a third report, Reproducibility and Replicability in Science. This report was released in 2019. So you see there was a series of these reports that came out one year after another. Its task was to examine reproducibility and replicability. First of all, what should even be the definitions of these? The two terms were being used interchangeably and sometimes in contradictory ways. And what are efforts that could improve reproducibility and replicability? This study was mandated by Congress. It was supported by NSF and the Sloan Foundation. It ends up defining reproducibility as redoing an analysis with the original author's data and code, and just making sure that the same result is obtained. Whereas replicability is getting consistent results by starting all over again, using as close as possible the original author's protocols, but collecting new data and doing a new analysis and making sure that the results are consistent. This report also recommends actions for researchers, funders, societies, journals aimed at strengthening replicability and reproducibility. One thing that came out of this report is that inconsistent results actually can help science move forward, because some systems are so complex that it is only by repeating the experiment finding that the results don't replicate, that the researchers can go back and figure out what went wrong here. What did we assume was not a variable in this research, but really is a variable. There's a well-known case where 2 labs were unable to get the same finding, and it was because one lab used pine shavings in the mouse cage, and the other lab used cedar shavings in the mouse cages. And that was enough to give them different results. So let me move on. Now, here's some themes from recent studies. There's just sort of integrating over these. There's a strong connection between openness and transparency and the reliability and trust in the research enterprise. These two things are not separate. In advancing reproducibility, replicability, and openness is difficult. It involves both top-down policy approaches, it involves bottom-up grassroots efforts, and it involves changes in the culture and incentive systems for doing science. These reports recognize that persistent multi-stakeholder efforts are needed to move the research enterprise in the desired direction, and new approaches and solutions need to work for researchers. And that's the part I said about making it easy. Making, you know, if you submit your paper to a journal and just by pressing a button, the data already automatically goes in the right format to the appropriate repository, that's making it really easy to ensure that the data are available. So let me move now to some of our ongoing and future activities. I spoke about the Fostering Integrity in Research report, recommending that a new body be established that helps to work across the scientific enterprise, all the way from the funders, through the researchers, to the journals, and finally to those who use the research for decision-making. And so the Academy stepped up to this charge, and we established something called the Strategic Council for Research Excellence, Integrity, and Trust. I am one of the co-chairs of this new Strategic Council. And as it says here, David Allison and France Cordova are my fellow co-chairs. This body convenes these stakeholders to develop ways to promote high quality research practices and to anticipate and address challenges to research ethics and integrity. For example, in what way are incentives misaligned? That the research institution is rewarding its faculty for doing X, whereas X may be counterproductive to the trust and the eventual use of that research. This board is supported by both the Moore Foundation and by internal resources here at the Academy. And we held our first meeting in October that was very successful. We already came up with a few quick wins that we want to undertake for the community, as well as some longer term goals that we know will be more difficult because they involve realigning some incentive systems. Here's a list of some other relevant activities that is currently underway and in development. We're hosting the U.S. National Committee for CODATA, which is allows us to connect to international activities in this sphere. We've got a roundtable on aligning incentives for open science. It's just now completing its first 3-year phase of activity and doing an analysis of what their successes were. This roundtable is, of course, very important for the Strategic Council too, but it's narrower in scope. It only addresses open science, not all the issues that impact the integrity and trust of research. We're also developing a toolkit for the Open Sciences Practices report. And the workshop proceedings have just been published from the convening to develop the toolkit. One of the Academy's publications is called Issues in Science and Technology. We publish issues jointly with Arizona State University, and it's publishing a series of articles in 2022 to advance ideas and spur discussion on how the scientific enterprise must evolve over the next 75 years. In fact, many of those papers are already out. And there's a workshop that will be held later this year on the future of methods reporting. Now, what can societies do? How can we work better with societies, and what are the appropriate roles for societies? So here's just a list of some of the ways that all of you who are in the leadership of various societies can get involved. First of all, hopefully you saw the call from the Office of Science and Technology Policy to provide response to a recent request for information, an RFI, on scientific integrity. I know I sent in my suggestions of what the government should do, and I hope all of you did too, and engaged your members in determining what should be suggested. One thing that I think is very important for scientific societies to take on is discipline-specific education and training around issues relevant to reproducibility and open science. It is not at all the same of what techniques are critical for the trust in, for example, biomedical research versus what it is in my own field, which is the geoscience, or what it might be in political science. Each of these fields has their own methodology for doing science, which means that sample size and statistics and best practices in that, and blinding researchers, et cetera, might be exceptionally important for, or not blinding, but making sure that you control for bias in researchers is essential in the social sciences. Whereas in the biomedical sciences, the issue is making sure that the researchers have been blinded, that you have a treatment group, that you have a control group, that the members of those groups have been chosen randomly, et cetera. So defining what is really essential for quality research in your own fields is a role for the scientific societies, and I can't imagine anyone who could do that better. Then next, I list up here discipline-specific standards and resources around issues of data sharing and stewardship. It can be entirely different if you're doing a survey versus a data set which is terabytes of multi-channel seismic data. So you have to establish what are your own best practices for data sharing and stewardship. Societies, most of them anyway, publish journals, and journals can be a great place to set the right tone with your investigators of what is required. Journals often have checklists that their editors go through and that the authors know if they can't check off things or at least show that it's not applicable to their work, their paper probably will not go out for review. So it's once you establish those discipline-specific best practices, making sure that the checklist checks that the work has been done appropriately. Many societies have been actively leading efforts to address some or all of these issues. And I'm interested in the Q&A to discuss how we can work together more effectively to take advantage of current opportunities to make progress. So I will end there and let me stop sharing my slides and be happy to answer any questions you have.
Thank you, Marcia. So let's see what we have.
Yeah, please just use the chat to ask questions or let Dr. Rubin know if you want to ask one.
Yes. Well, while we're waiting for questions to show up on the chat, again, I want to thank you for your presentation, which really did a couple of things. It just showed the really extensive amount of activities that the National Academies has been involved in over the years, and is really covering a lot of the bases. And also ending with the scientific societies slide, and the request for a number of things is important. So the question I have is also one on engagement. In addition to the societies doing things, are there other steps that your experience shows that the societies can do to help get their members engaged? Because often the things at the top level of OSTP or the academies is not the thing that they resonate to. So I'd like your advice on that.
Yeah, well, thanks for that question. So I go back to my days when I was leading the USGS. The USGS as an organization had something called their fundamental science practices. And these fundamental science practices were like a cookbook of how the USGS collects data. Data on water quality, data on water quantity, data on analyses of oil from oil spills, data on artifacts and how they're dated, et cetera. They have a recipe for how this is done so that a different team from the USGS could go back to the same well that was tested a year ago and test that water quality. And they could be sure that the data was comparable to the previous data, that it didn't all have to be done by the same person or even the exact same analytical device. They were all intercalibrated to make sure that the time series were intact and that everything could be compared to previous data sets. I think that it's something like that fundamental science practices that really that need the engagement of all of the members of a society. I belong to the American Geophysical Union. American Geophysical Union does everything from planetary sciences to microbial research. And there are different fundamental science practices that would be required from each of those. And I think that societies can also work with relevant federal agencies as well, like social scientists might want to work with the census, or the AGU could work with the USGS to make sure that everyone agrees this is how we get good, reproducible, quality data that can be understood over time.
Thank you. We have a lot of questions in here, so I'm going to select those, trying to cover as much as possible before time runs out. So first, Philip Tarrant says the academic makeup of the Strategic Council suggests we may be missing the, quote, voice of the customer, end quote. How do we know we are taking steps that will address the increasing public distrust of research results?
Yeah, okay, so that's a really good question. Right now, we do not have a member of the Strategic Council that I would consider is Joe Public, that might be able to help us understand, you know, from the standpoint of this question, what a person from the public believes. But unfortunately, I'm not sure I can find someone out there who is absolutely representative of the public. I think there are many different publics out there. We do have industry on the panel because I think industry is one of the most important consumers of science. And plus they not only consume science, but they also generate science. And so they are in there both as a generator and a consumer of science. And as you recall, the whole issue of reproducibility of research started at, I believe, Amgen, when it was discovered that many of the fundamental papers in cancer biology were not reproducible. We also have Kathleen Hall-Jamieson on our committee, who is an expert in communicating science to the public. She has devoted her career to understanding how science goes wrong in the communication part and how to build public trust in science through better understanding of the scientific method. Science isn't a list of facts, so people shouldn't be concerned if, 10 years ago, coffee was good for you and this year it's bad for you or something. New evidence comes in. That's the way science moves forward. And Kathleen is an expert on that. And we're really lucky to have her on the council.
Thank you. Sarah Nasser asks, can you please speak more about how societies can help advance the ways we provide reward and credit for researchers who do a good job of sharing data?
Okay, so I just sat on the jury for a foundation in Berlin, the Einstein Foundation. And the Einstein Foundation, with help from members of its jury, established a series of awards that are very lucrative, that reward people for reproducibility, open science practices, for quality in their research. And there's one award for a person, one award for an institution, and one award for an early career researcher. We just had the presentation of those awards last week. And Paul Ginsberg, who started the archive, won in the individual category because the archive is the granddaddy of them all. It started the preprint revolution, which has made science more accessible and more quickly accessible. In the institution category, the Center for Open Science in Virginia. I recused myself in that category since I'm on the board, but I think they were a very worthy recipient. And two young researchers who are trying to get more data and better data and more open data on early childhood learning and cognition won the Early Career Research Award, and they will use their award to fund their research. Now, there's no reason why every one of your societies couldn't have an award, either for an early career person or anyone that rewards open science practices, quality research, reproducible research, et cetera. Right now, there's just not many rewards for it. And I think that societies could step up in that area.
Great suggestion, thank you. There are at least a couple questions on international aspects, so I'll put a couple of them together. Shall we start? How can we as societies work best with international communities to coordinate our work with discipline-specific data sharing practices? And Stuart Chalk, what is the best way that international unions, he represents, IUPAC, can engage with this effort?
Yeah, so let me take the first one first. So the advantage of many of your American societies is that they have international members. I know the AGU has lots of international members. ESA has international members. I would start by approaching your own international members and say, who should we be partnering with? And then this really relates to the second question too, which is the impact of these international unions. There are international unions in every facet of science. And if, For example, a few of the societies working through your international members could get together and come up with some best practices, some standards, some styles, etc., and propose them to the international unions. That is, that could potentially be a route to wider dissemination.
Thank you. A note of interest for those who are providing their questions or information in the chat. The chat will be captured and will be available along with the recordings and the slides at a later date. Next is from Megan O'Donnell, who comments, there seems to be a lot of uneven education and expectations with data among journal editors, not just publishers, such as societies. Have discussions reached this level yet?
Okay, so I do have some experience with this because the Academy publishes PNAS. And PNAS, of course, covers all of the sciences. And there is really a huge difference from editor to editor in how they are addressing quality and reproducibility. But I think this is a really great idea for the Strategic Council of another early win. And that is to get some training to journal editors. Because if the editors, if everyone knows this is what the editors are looking for, then that is a great incentive for the researchers to follow those best practices. So I think I love that suggestion. I think it's terrific. Educating the editors, and then the editors will propagate that to their author communities.
Thanks to you, and thanks to Megan. Brooks Hanson comments, Marcia, many thanks. Fostering reproducibility will also require real investments in data infrastructure. For example, supporting domain repositories consistently. What role do you see the Academy, particularly in working internationally with other academies and the US government to foster this support?
Yeah, so Brooks, this is, you know, you've hit the nail on the head. This is a really tough issue. We do have members, international members on the Strategic Council who represent the best and brightest from other countries. And we have members of funding agencies, Skip Lupia, who's at NSF, and we have people from NIH, people from EPA on the Strategic Council. I know that each of these federal agencies feels that they have not found the sweet spot between being able to fund new data collection and being able to fund excellent repositories for what has already been collected, such that data is accessible and usable. There are far too many, in my opinion, repositories who take data in, but no one knows how to get it out. Or if they get something out, they don't know what it means. So I think before we throw a whole bunch more money into more data repositories, we have to solve this problem of what makes data, how to capture all the relevant metadata and to make it usable by other people. I think we have to start by training students to begin with. How, and it should be one of the greatest achievements of a scientist to be able to say, I collected this great data set and 10 other people have used that data set for discovery.
Thank you. Seth Murray comments, making it easier would be to have professional data sciences help work with PIs to get data shared, open and fair. Making it beyond easy would be artificial intelligence that could find information on PIs' computing infrastructure and suggest how to make it open and fair. Any efforts towards these?
Yeah, so one of the reports that I mentioned actually did talk a lot about data professionals and how we need to establish and promote a new cadre of data professionals. And I think, you know, I love the idea of AI too, but I think until we get a professional group that actually knows how to properly document, archive, and deal with complex data sets, we won't even know how to train the AI to do it. So I think that is the first step, and that is a major recommendation in one of those reports. The issue too is, I think that there's enough momentum behind this, that if you put in money in your proposal to fund a data professional, I think the funding agencies will be supportive of it.
Thank you. Brian Wester provides some information. It's not a question. In the chat, he says, this might be of interest in an open research toolkit by the Australasian Research Management Society and the Council of Australian University Librarians. So take a look in the chat, and again, that will be saved.
Terrific. I'm glad the chat's going to be saved, because I'm sure there are a lot of great ideas coming out in this chat, because this is clearly a very knowledgeable audience.
Zolt Silberer says, an important part of openness, standards, and action is the activities of universities. We can't expect the government to dictate this. How are you working with universities to ensure that credit, tenure, and young researchers are set up for this in the future?
Yeah. So that is certainly, so we have the Strategic Council that's dealing with that, because we see that there are misaligned incentives of what universities are rewarding versus what funding agencies are expecting and what journals want to have. So that is one of the big topics we are addressing, particularly because we think that the situation in universities has, in many cases, gotten so dire that young people just don't even want to pursue academic careers in science anymore. Maybe many of you saw that article that came out in Nature day before yesterday, in which they surveyed young researchers in industry and in academia, and found that across the board, the young up-and-coming people were much more dissatisfied with academia than with industry. We have to address that.
The next comment and question from Bruce Wilson is long, and so bear with me. I am going to read the whole thing, and if we need to go back, I will. He says, I agree with Todd Carpenter that standards are important, and those standards need to be easy to use. As someone who manages a data center with a high degree of curation, it's surprising and frustrating how often we run into cases where researchers find getting things compliant with the Climate and Forecasting Convention for Net CDF. And the same is true for the frequency. We find significant usability issues with submitted data, like different values for missing data in different files or inconsistency in variable names. How can we help researchers make their data more usable by others?
Yeah. So I think this is, this happens in every field, when I was a young researcher starting out in oceanography, all of the data from marine geophysics went into something called the NGDC, the National Geophysical Data Center. And everyone knew what the NGDC format was for submitting your data. So the instruments on the ship were set up to collect data such that it was NGDC compliant. And everyone's computer programs that analyzed marine data all were set up to read NGDC format. And so I think that's the kind of cross-sector work we have to, or workflow that we have to set up so that the instruments collect the data in the format we need, and then the computer software all reads the data in the format. And I'll also say the data was automatically submitted from the ship to the NGDC. As chief scientist, I didn't have to go collect a bunch of data sets and reformat them and send them to NGDC. It just went right from the ship to the NGDC. So I think we need to have more workflows set up like that to ensure that it is easy and it is routine and that there aren't errors, because I'll tell you the frustration with just journals trying to understand whether things are compliant is really high, and it's an expensive problem.
Thank you. Susan Borda has provided a link to another good resource on reproducible research, so check that out. Stephen Dix, following up on an earlier question, says, now that we've stated our goals, describe the current state of things. How do we influence funders to provide resources on the ground so that data curators can build out the infrastructure that will directly address the data challenges before us?
Yeah, so again, going back to my time at the USGS, the data people there were real scientists. They weren't considered someone's tech. They were their own profession. They know how to deal with big data. They knew how to do data analysis. They knew what to look for in terms of flags that data was fishy, et cetera. And they were hard money funded, just like anyone else was at the USGS. And until we establish that kind of infrastructure across all of the sciences, it's really going to be very difficult to get where we need to be in terms of the professionalism with which we deal with data.
Thank you. So on the chat, for those who aren't following it, we've got support for some of the questions. People are kind of registering their votes of approval of the questions, and some people are interacting with each other. So I'm going to actually select a couple things that I think are of relevance, and in one case, add a question to one thing. So here's a comment from Paul Guinnessy, AIP Physics Today. Archive, ARXIV, is a wonderful platform, but it still hasn't got a long-term viable business model. As we've seen just today with the purchase by Wiley of Knowledge Unlatched, nonprofit OA is hard and can have long-term risks without strong backing. If you have any comment, fine.
Oh, absolutely. I mean, I talked to Paul Ginsberg about Archive. This has been a labor of love for him. And Paul's getting on in years. He doesn't know what's going to happen to Archive when he is no longer around to maintain it. And the Center for Open Science, where I sit on the board, they host a number of preprints. And at first they were just trying to do the preprint posting on the margins. Now they realize that's not possible anymore. They have to have a legitimate business model for it. And they've done that. They've actually been successful. If you look at bioRxiv, its funding all comes from philanthropy. And that is never a good long-term solution, because philanthropists decide, we want to move on to something else. We want to do something new. We don't want to keep doing the same thing. So coming up with a viable funding model for these preprint observatories, as I say, the Center for Open Science has been able to do it, but others need to either look into what they're doing or come up with their own solutions. Because, but I think one thing that I have to say it has shown is that there really is no free lunch. Back when I was editor of Science, people used to say, well, why does science, charge for its subscriptions? The authors are doing all the work and they just post them. Well, it's not really that simple. Even if you don't have a peer review system, which is what happens with the preprints, it still costs money to host the platform, to have backups for it in case there's a crash or something goes down, to moderate things, to make sure that there aren't people coming in, selling, Viagra on archive. You don't want that to happen. So it can be an expensive thing. And as you know, archive doesn't allow commenting, I don't believe. And it's because of the cost, whereas bioRxiv does.
Thank you. We have a comment and a long question that I'm going to merge together by reading them one after the other that touch on a very important issue related to universities. So first, another comment by Isolde Silberer. So he goes to Seth. He says, Seth, I agree and entirely support societies taking the lead. Yet, academics are part of National Academy of Sciences and other committees and do not pressure for change in merit, credit, and tenure. Societies can help, but the provost, deans, and presidents really need to step up. Pause for a second, and then a slightly even a longer one from Jing Liu. Another infrastructure question is how universities can be motivated to invest in developing institutional support for data sharing. I'm going to skip down because it's long. Also, there are many tools, platforms out there, but user interoperability vary greatly, and many researchers still don't know which to use. So that's a combination of a couple of questions. I'm going to start with the first, which is for many of us who deal with universities and with university administrations, we learn very quickly that deans, provosts, and sometimes presidents play key roles in these kind of issues. So we'll take that first half first, and I turn it to you. Sorry.
Okay, so let me sort of try to amalgamate a lot of these thoughts together. Basically, people are saying, in order to achieve what really needs to happen, universities have to change. I mean, that's the bottom line. Okay, let's look at how quickly and nimbly universities change. University faculty still dress up in medieval garb once a year to confer degrees. There's probably no institution in the world, other than maybe the Vatican, that is more rooted in the way things have always been done. We've seen a number of sort of technical revolutions happen that could have changed universities and really haven't. For example, remember when, well, most of you are too young to remember this, but I remember when correspondence schools came out. They didn't replace universities. You weren't just going to learn by getting things mailed to you. And then online universities happened. That they have never achieved the stature or the quality of our brick and mortar universities. And now virtual learning, where students can interact with faculty at the university without being physically present. Maybe that will take root, but the issue has always been that the university is a community of interested minds wanting to learn from each other. It is not a direct transfer from the faculty member to the student who's the recipient. There's an exchange between students, exchange between faculty, exchange back and forth between students and faculty. And that's the environment that needs to happen. But because the university is this community of learners, that community of learners can rise up and say, we want things to change, but that's what it's going to take to make it happen. They're going to have to get together and all hold hands and say, this is what we want. We've already seen some trends in universities that I find very troubling. Fewer tenured faculty, more term appointments for instructors. And so you have to be careful that in motivating change, that you don't lose things that are also important to faculty and students.
Thank you.
I'm sorry, that's not a very specific answer, but
no, that was excellent. So Todd Carpenter has provided a lovely quote from Kurt Vonnegut. So I just want to read that. It says, quote, "Another flaw in the human character is that everybody wants to build and nobody wants to do maintenance," end quote. Kurt Vonnegut, and has gotten a lot of support on the chat. Dr. Donna J. Nelson says, "One challenge is that open data are at risk of being reported by other researchers who claim the data as theirs. It's easy to show and report who actually owns and generated the data, but little is done to stop the illegal reports. This discourages openness." That's a comment, but you might want to have a comment.
Yeah, so I have sort of mixed emotions about that. When I was an oceanographer and put my data into NGDC, nothing said it was my data. Nothing said it was my data. The ship that collected it was listed. What cruise was listed. So if someone really wanted to try, they could go back and see who the chief scientist was for that leg of the cruise. But I basically feel like I got first crack at this data, and that was my reward. Otherwise, it's everyone else's data. But then on the other side of that, let me give that's the yin, let me give the yang to it. There is something to be said for being able to know who collected the data, because I know in my field, there are some people I absolutely trust with my life to have gotten excellent data, and other people that I honestly think are kind of sloppy. And so knowing who collected the data does help me somewhat in understanding what I should trust. Now, that's less true for this oceanographic data set because it was collected by standard instruments using standard methods and quality control before it was put in the data archive. But in some other areas of chemistry and places like that, I think knowing who collected it is important.
We have a number of other comments on that issue, so I invite those to read the chat or look at the chat later. Another comment, Biru Zhao of McGill says, "The danger of having data professionals use soft money funding is that findings are periodic. This may bring discontinuity to research data maintenance. This may also put significant barriers to young researchers in certain disciplines that simply cannot I think he meant afford a data professional in their research program. This will make the rich richer and the poor poorer." Any comments?
Yeah, so I certainly understand those risks. As I say, at the USGS, we funded the data professionals just like we funded every other scientist or technician that was working at the USGS. It could be that, yeah, here's one possible model, that given that we're getting pretty good now at interacting collectively through the internet, maybe the model is not that the data professional resides at the institution. Maybe the data professional resides at the repository. And when you're funded in a certain field, the funding group allocates you so much of that data professional's time to help you with your work. And you establish a relationship with them. You talk to them before you finalize your data collection plan. et cetera. They provide you with tools to do it. So that's another funding model that could be much more stable than having the data professionals associated with the PI.
Thank you. I want to thank Marcia, Dr. Marcia McNutt, for her leadership in many domains over many years that has really changed the landscape of these issues. I also want to thank, at the close of this year for this seminar, I want to make sure that I thank the participants and collaborators supporting the event. So thank you, everybody. Time is over. Again, thank you, Marcia. We look forward to cooperation in the future.
Bye
all.
everyone. Thank you.